For more than 70 years, we thought our map of the solar system was complete. It was a familiar, tidy collection of 9 worlds orbiting our sun. We memorized their names, built models in our classrooms, and saw one, Pluto, as our distant, icy outpost. It was a comforting fact. But far out in the frozen darkness, a ghost was lurking. Its discovery wouldn't just add a name to the roster of planets, it would trigger an identity crisis for the solar system itself, forcing astronomers into a bitter conflict, and in the process, redrawing our map of the cosmos forever. This is the story of the world that, true to its name, sowed discord in the scientific community. Join me as we travel to the chaotic outer edges of our solar system to meet Eris, the world that started a war over the meaning of a single word: planet. Before the turn of the millennium, the solar system felt settled. We had the 4 rocky terrestrial worlds, the 4 gas and ice giants, and then there was Pluto. Discovered in 1930, Pluto was always the oddball. Its diameter was smaller than our own moon, and its orbit was a wild, tilted ellipse that swung it across the path of Neptune. For decades, these were just its charming eccentricities. Pluto was the beloved underdog, the smallest and most mysterious of the 9. This was the solar system lodged in the public consciousness. But astronomers suspected Pluto wasn't alone. Out in the frozen darkness beyond Neptune, in a region we call the Kuiper Belt, they had been finding other small icy bodies since the 1990s, frozen relics from the dawn of the solar system. For a time, they were all much smaller than Pluto, allowing it to retain its special status as the undisputed king of this third zone. It was both the 9th planet and the largest known Kuiper Belt object. This delicate balance, however, was about to be shattered. At the Palomar Observatory in California, a team of astronomers, Mike Brown, Chad Trujillo, and David Rabinowitz, had embarked on a monumental effort to take an inventory of the sun's most distant subjects. They were using a powerful telescope to capture images of the sky, looking for the telltale sign of a nearby object: slow, deliberate movement against the backdrop of fixed stars. The work was painstaking. Then, on the 5th of January 2005, while re-examining images first taken on October 21, 2003, Brown spotted it, a single, faint dot of light moving at a glacial pace. He knew instantly this was significant. It was bright, meaning it was either large or highly reflective, and it was moving far slower than anything they had found before, meaning it was incredibly far away. The team tracked the object, and their calculations delivered a startling conclusion. Based on its brightness and extreme distance, this new world was not just as big as Pluto, but likely even more massive. The discovery was so significant that it created an immediate and profound logical crisis. If this new object, Eris, was a planet, then what about all the other large bodies being found in the Kuiper Belt? Where would you draw the line? As Mike Brown put it, we were either going to have to add new planets or subtract one. The discovery didn't just present a potential 10th planet. It exposed that for 75 years, astronomy had operated without a clear, scientific definition of what a planet actually was. The formal announcement of Eris in July 2005 was the modern equivalent of tossing a golden apple into the halls of astronomy. It ignited a scientific war over the very definition of a planet. The problem was simple, yet profound. If Pluto was a planet, then Eris, its more massive twin, certainly had to be one as well. The International Astronomical Union, the global body responsible for astronomical nomenclature, was forced to act. At its 26th General Assembly in Prague in August 2006, the question was put to a formal debate for the first time in history. The debate was vigorous and exposed a deep rift in the community, splitting it into 2 main camps. On one side were those who advocated for a geophysical definition. If an object is massive enough for its own gravity to pull it into a nearly round shape, it should be a planet. Under this definition, Pluto, Eris, and potentially dozens of other bodies would have become planets. On the other side were those who favored a dynamical definition. They argued that a true planet must be the dominant gravitational player in its orbital zone. In the words of the final resolution, it must have cleared the neighborhood around its orbit. The vote itself was fraught with controversy. Held on the last day of the 10-day conference, only 424 astronomers remained to cast their ballots. When the votes were counted, the dynamical definition had won. The IAU passed a three-part definition for a planet in our solar system. It must be in orbit around the Sun, be in hydrostatic equilibrium, be nearly round, have cleared its neighborhood. Pluto and Eris met the first two criteria with ease, but they both failed on the third. Their orbits lie in the crowded Kuiper belt, a space they share with thousands of other icy objects. With that vote, the solar system was officially reduced to 8 planets. A new category was created, dwarf planet, for objects that meet the first two criteria, but not the third. Pluto and Eris became its founding members. The decision was logical, but the public reaction was swift and emotional. For many, Pluto's demotion felt like an injustice meted out by a small group of scientists. The outcry was so significant that the American Dialect Society voted Plutoed, meaning to devalue or demote something, as its 2006 word of the year. In a fitting tribute to the chaos it had caused, the Discovery team officially named their object Eris, after the ancient Greek goddess of strife and discord. Its tiny moon was named Dysnomia, the mythological daughter of Eris and the spirit of lawlessness. The names were a perfect acknowledgement of the scientific and cultural uproar the Discovery had unleashed. Eris hadn't just been a discovery, it had been a catalyst. This story, of how one discovery can completely reshape our map of the cosmos, is at the very heart of astronomy. If you love these deep dives into the cosmic mysteries that force us to rethink everything, make sure to subscribe for more stories from the frontiers of science. And let us know in the comments, what do you think is the next great discovery waiting for us out in the Kuiper belt? Beyond the controversy, it's time to journey to Eris itself and understand the nature of this renegade world. It is one of the largest known dwarf planets in our solar system. For a long time, it was thought to be Pluto's larger twin, but in 2010, astronomers measured it with incredible precision as it passed in front of a distant star. The result was a surprise. With a diameter of 2,326 kilometers, Eris was almost exactly the same size as Pluto, in fact, slightly smaller. This revealed the most crucial difference between them. Eris is 27% more massive than Pluto, and packing that mass into a slightly smaller volume means it must be significantly denser. This points to a very different internal structure. While Pluto is a mix of rock and ice, Eris must be predominantly rock, with only a comparatively thin mantle of ice on top. A rocky heart in a frozen shell. And that shell is one of the most brilliant surfaces in the solar system. Eris has an incredibly high albedo, reflecting about 96% of the sunlight that reaches it, which suggests its surface is covered in a thin layer of frozen nitrogen and methane ice. This dazzling brightness is likely due to a phenomenon called atmospheric collapse. As its extreme orbit carries it into the deep freeze, its thin atmosphere freezes solid and falls to the surface as a fresh, bright layer of snow. That orbit is truly extreme. It takes Eris 557 Earth years to circle the Sun, on a huge ellipse that takes it from 38 to nearly 98 astronomical units away from the Sun. Sunlight's journey to its surface can take anywhere from 5 to 14 hours. From its surface, the Sun would look like little more than a very bright star in a black sky. The orbit is also steeply inclined, meaning Eris spends its long years soaring high above and plunging far below the plane of the main planets. In the end, Mike Brown has been called the Pluto killer, but this misses the true legacy of his discovery. Finding Eris didn't kill Pluto, it was a mirror. It revealed Pluto's true family, making our solar system larger, more complex, and more interesting. The discovery didn't shrink our solar system, it expanded our understanding in the most profound way. We no longer have a flawed model of 8 planets and one strange outlier. We have 8 classical planets and a vast third zone beyond them, a swarm of thousands of icy dwarf planets whose existence we were only just beginning to grasp. Eris and Pluto are the kings of this realm.
The story of Eris is a powerful reminder that science is not a collection of static facts, but a dynamic, unfolding process. A process that sometimes forces us to let go of old, familiar ideas to make way for a grander and more truthful vision of the universe. Eris, the goddess of discord, ultimately brought a new kind of order, reminding us that with every new point of light from the darkness, our understanding of home is bound to change.